Hello! In this video we're going to look at Bernoulli Trials. I hope I'm pronouncing that right. I think it's Bernoulli Trials. I am not a super math whiz. I struggled through these math problems just like you might be doing now. And so, I'm going to show you my tricks for learning these things and my tricks for solving these problems. They may be a little different than what your instructor teaches you. There are many ways to solve math problems, so choose the one that gives you the right answer but works for how you can think about math. So I'm going to show you my methods. Again, this is Bernoulli Trials. This is section 3.5 in the book Finite Mathematics by Daniel P. Maki and Maynard Thompson. This is something you'd see right before your big midterm at Indiana University, M118. And I gotta admit, I love Bernoulli Trials. Why? Because it is plug and play. You got a formula, you got some numbers, and boom, you are just done. It's beautiful. And so they can make these trickier, but it's not so bad. So we're going to do a problem that was recommended by one of the instructors. I think it's pretty standard to something you'd see on a test. So let's go ahead and do our first step, which is reading it, and then we're going to write down what we know, and then we're going to solve it. So problem 31 says, a multiple choice examination consists of 10 questions, each question with 5 choices for an answer, and each question has exactly one correct answer. 2 students answer the questions by guessing. Assume the answer sheets are prepared independently and find the probability that each student answers exactly 4 questions correctly. So let's go ahead and write down what we know. Okay? So the first thing we know is that there are 2 students. Oops, there we go. My tablet's running a little bit slow today. We know that there are 10 questions. We know that each question has 5 options. And we know that there is one correct answer for each question. And I'm assuming that none of these options are none of the above, because it's never none of the above. I don't know why they even put that there. It is never none of the above. So what are they asking? Well, what is the probability that each student answered exactly 4 questions correctly? And that's a fun one. So the first thing that's interesting there is exactly. So we don't need to worry about multiple situations. Each of these students answer exactly 4 correctly. We're just going to call it correct. So how would we do this problem? Well, before we do this problem, let's talk about what the actual Bernoulli trial formula is. It's super easy, and I love it. I think you're going to like it too. So what is the Bernoulli formula? Well, it's really straightforward. The probability of any number of R successes, just to keep, in sync with what you've got in your book, is equal to the combination of n, choose R, times the probability of a success to the rth power, that's kind of weird, to the power of R, we'll say that, times Q to the power of n minus R, and that's it. It is just that easy. So what is Q? You're going to be asking me. Well, Q is the chance that it's going to fail. And this is the only place where these problems get tricky, and this problem does not particularly get tricky, but sometimes they'll say that failing is what they want to know. So that's where we're at. Q in this case is 1 minus P. So that's all it is. This is the chance that you win. This is the chance that you lose. That's it. And the chances, when you add them together, they have to be 1. So if P is 40%, for example, Q is 60%. Just that easy. So let's go ahead and plug our numbers into this formula. So let's see. The probability of 4 successes. And actually, before I do that, I'm going to step back and I'm going to tell you what I'm going to do. And the way they make this problem tricky is there are 2 students. And we need to know the chance that each student answered exactly 4 questions correctly. So we're going to step back and we're just going to solve for 1 student. And hopefully that will make sense at the end. I'm going to explain my reasoning when we get to that point. but we need the first student, student A, let's call him Anna. Student Anna needs to get exactly 4 correct. And student B, student Anna, I don't know, the other student, needs to get exactly 4 correct. So if that "and" sounds kind of familiar, you should be thinking that it is. We're going to multiply the probability that student A gets this exactly 4 correct times the probability that student B gets exactly 4 correct. So it's student A and student B get 4 correct. And so that's why we can solve for just one student, because they're both guessing. They're both exactly equal in terms of the likelihood of getting 4 correct. So let's go ahead and plug our numbers in. We're going to solve for one student, as I said. So the probability of 4 successes is equal to, and all of this should be familiar because you know how to do all of these things. So the combination of 10, choose 4, right? Because there are a total of 10 questions, and we want 4 of them to be correct. The probability of success, so if there is one correct answer out of 5 options, that is 1/5, and that is to the to the power of r, which is 4, times q, which is the chance of failure. So there are 4 wrong answers to the n minus r, or 6. So before we go any further, let's kind of talk about this. This is the combination, the number of ways you could choose 4 out of 10, times the probability of choosing the one right answer. So there's 1 out of 5 right answers to the 4th. So there's 4 ways we could choose this, times the probability of choosing a wrong answer. There's 4 out of 5 ways of choosing a wrong answer to the 6th power. So that's what that is. And let's go ahead and solve that. I mean, that's all this is. You just plug it into the formula and you go, and it gives you the answer. That's why I like these. You have to know your formula though, so make sure you put it on a note card and memorize it, because it's going to come in really handy in the next couple of chapters. You're going to see it a lot. So at this point, our problem is just to do the math, and it's a little nasty. Most of the time, you could pretty much leave it at this. And so if I were going to do that, we know that this is for one student, so if I were to turn this in, or it's going to be on the test, what they're going to show you is something like this. It's going to be the quantity combination 10 choose 4 of 1/5, or typically when they talk percentages they get kind of cranky and they want a 0.2, so that's 20%, right? 1/5 is 20%, to the 4th times 0.8 to the 6th, and quantity, and that whole quantity squared. And that is actually a legit answer. You could turn that in and they would be okay with it. We're going to go ahead and solve this because I think it's valuable. I think it kind of hits it home that this is actually actually math that actually gives you a percentage. And but that would work right there. That's the answer. You could stop watching the video right now. I've given it away. There you go. And on a test, what you'll see is a bunch of options, A through D or whatever. E will be none of the above. It's never none of the above. And it would be, combination, I don't know, make up some numbers, 12 choose 4 of 0.9 to the 5th to whatever. And all of them would be wrong except for one, which would be this one. So let's go ahead and actually do the math and solve this. But as I said, that is a perfectly legit answer. So what is combination 10 choose 4? And this stuff should be, second nature to you, but I'm going to go ahead and solve it. So that should be 10 times 9 times 8 times 7 times 6 factorial. And this is actually how I solve combinations by hand, over 6 factorial times 4 factorial. Okay, so let's see, I'm going to choose a different color. So 6 factorial goes away. 4 factorial is actually 4 times 3 times 2. And so 4 and 2 go into 8. 9 can take that 3, and 9 becomes 3. So this turns into 10 times 3 times 7, which turns into 210. I went blue, but I'm okay with that. So that's that part. So let's go ahead and write this again. 210 times 1/5 5th to the 4th times, what is that, 4/5 to the 6th. And I'm going to admit at this point I plugged this puppy into a calculator because it is really, really gross. So this turns into, and this is another reason why that other answer is okay. 1/5 to the 4th turns into 0.0016. 4/5 to the 6th turns into 0.262144. And they're never going to make you do this stuff manually on a test. So that turns into 0.088080384. And remember, this is for one student, right? So what do we want to do? Well, we want to square that. So 0.088080384 squared equals, let's see, that is, I'm going to pretend that I did that math, but actually I plugged it into a calculator, 0.00776, and that is our answer. So let's go ahead and back up and talk how we went ahead and solved this, and hopefully it'll make some sense for you. Okay, I'm going to go ahead and zoom us back out and take us to the top, and we're going to figure this out real quick. So what did we do step by step? Well, let's choose a nice happy green. I like greens because they cited the problem right. So we wrote down what we know, and one of the important key things here is that we were talking about exactly 2 students, and that comes up several times, and it would be really easy, and what a lot of instructors would do on tests or in the homework would be give you an option where you didn't take into account that there are 2 students who need this to happen, both get exactly 4, and so that's a big deal. We wrote down the other stuff we know. We also know that it's exactly 4 correct, so that's also kind of important. Then we wrote down what the formula is. And again, I love this formula because it is super straightforward. It is combination NR times P to the R times Q to the N minus R. And so the total number of things chosen R at a time. P is the probability of success, whatever you define the probability of success, to the to the power of R, which is the number of successes, times Q, which is 1 minus P, so that is the number of failures, or the percentage or chance of failures, times the number of failures, which is N minus R, to the N minus R power. And so we went ahead and we solved for 1 student. That's a big deal. I keep bringing that up. So for 4 successes, the probability of 4 successes, that was the combination of 10 choose 4. We have a 1 in 5 chance of getting the correct answer. We need 4 of those correct. We have a 4 in 5 chance of getting the wrong answer. If we need 4 correct, that means we need 6 incorrect. And so because this was for only 1 student, we need to make sure we square this, or we multiply it by itself. And this right here is totally a valid answer, and most of the time you could turn that in, and that would be fine. You got to make sure you have this squared here in this particular problem. Oftentimes they'll do something that just kind of throws it off a little bit, so you can't just plug it in. But we went ahead and we solved it. We did all this math. This is all math. We found our combination 10 choose 4. We found 1/5 to the 4th and 4/5 to the 6th. We multiplied all that together using our handy dandy calculator. That was only for 1 student, remember? Kind of still a big deal. And so we squared that, and that gave us our answer, which is 0.00776, or 0.776%. And that is our answer. So Bernoulli, totally awesome. Memorize the formula, plug it in, Bob's your uncle. It's just that easy. So go ahead and play with them, do a couple other problems. I think you're going to find this one of the easiest things around this time in finite mathematics. And you're going to be using Bernoulli a lot. So, check it out, get comfortable with it, memorize that formula, write it on a little card, pull it out, look at it, just make it part of your brain because you're going to be using it a lot.